will be at factoring. Do you remember? This is something you did last year as well, multiplying 5x into this binomial and getting a final result versus starting with the binomial and then taking out a GCF. Do you remember that? What was this process when you had two binomials and you're multiplying? A FOIL to get that versus starting with the multiplied version and coming up with the two factors. So we're going to review how to do that. So the first method of factoring is common factoring. When factoring, first begin by looking for common terms. It could be a number, a variable, or both. We remove the common factor by dividing it out from the polynomial. Place the common factor in front of the parentheses, brackets, with the remaining polynomial inside the parentheses. Once this is done, the same number of terms as the original should be inside. So, who can tell me what the GCF, or the common factor, is between 8x minus 32y is? And 8. There's no variable that's common. So what are we left with if I factor or divide the 8 out of the first term? X. And what am I left with the second? Minus 4y. Again, you have to have the same number of terms as what you started with, right? So what would the common factor here be? A b. And what am I left with? Okay, you have to have the same number of terms, so you need a placeholder there. So what do we need for the first term? What is b times negative b? Negative b squared, is that what I have there? No, so what would I have to put here? A 1 minus b r cubed c. Now watch, if I multiply this out, I should get what I started with. If you didn't have the placeholder there, you wouldn't have two terms, right? Okay, what's the GCF here? 3 and an x. Then we're left with x squared minus 2xy plus 3y squared. Very good. Okay, perfect square factoring. A difference of squares is a binomial where both the first and the second term are perfect squares. An example is x squared minus 16y squared. Does everybody see x squared is a perfect square and 16y squared is a perfect square? Does everybody know what I mean by perfect squares? Yes? Okay, they are separated by a negative sign. You cannot factor a binomial by difference of two squares if it's addition. It only works if it's subtraction. Factoring perfect square results in two similar binomial brackets that differ only in the, I'll say, positive or negative sign. So if I were to factor x squared minus 16y squared, I say, oh, there's two terms and it's a difference. It must be difference of two perfect squares. What's the square root of x squared? X. What's the square root of 16y squared? 4y. And then the only difference between those two factors is one's a plus, one's a minus. Does it matter which order I put it in? No, it's multiplying. Remember, multiplying has that nice property where it doesn't matter which order you multiply it in. 2 times 3 and 3 times 2 will give you the same thing. Okay, do you want to try the next 5? Okay, I'll give you a moment to do that. So B, what did we get? 5x minus 7y times 5x plus 7y. Very good. What'd you get for the next one? Not factorable. It's not a difference of two perfect squares. It has to be a difference. This one, before I do it, I would probably rewrite this as 36 minus y squared. Because you need to have it written as a difference, right? Okay, so what do we get? 6 minus y, 6 plus y. Does anybody have anything different? It does matter. The y has to be the one with a negative, not the 6. So, okay, so that's where I was going with this. Did anybody factor this out first and then had it like that? Then you would get negative y minus 6, y plus 6 like that with a negative in front. That would be totally acceptable, probably the best answer. Okay, the next one is not two perfect squares, so I would look to see if I can factor something out, and I can. What could I factor out? A 3x. And what am I left with? X squared minus 16. Hey, that's a perfect square difference. So what's that end up being factored to be? 3x, x minus 4, x plus 4. Who got that answer? Ooh, impressive. Okay, how about this one? Difference of two perfect squares, so what is it? 1 minus 4x squared, 1 plus 4x squared. Now my question to you is, did anybody recognize this was another difference of two perfect squares? So it can be factored even more. Okay, so what can that first factor be factored into? 1 minus 2x, 1 plus 2x. Yeah? So sometimes you factor once and you might have to look to factor again and again, right? Especially difference of squares, sometimes that ends up being another difference of squares. But you should always be checking to see if there's a GCF you can take out first. Okay, trinomial factoring. When factoring a trinomial, you need to ask yourself, where did it come from? Trinomials are most commonly the result of multiplying two binomials. Remember what a binomial is? It's a polynomial with how many terms? 2. And most of you learned to multiply two binomials together using the FOIL technique. Now, for now, we will consider only trinomials where the leading coefficient in front of the x squared is 1. Those were the easiest ones, right? If it is not 1, try making it into a factor. Try making 1 by factoring out a common value. Okay, so anyways, does everybody understand? The x squared comes from the two first terms multiplied, right? And the last term comes from the last two terms multiplied. The middle term is the sum and the difference between the outside and the inside of the FOIL. So does everybody see how I get FOIL? First, outer, inner, last. Yes? Trinomials will factor to two binomial brackets. I think that's what I wanted. So, factor x squared plus 5x plus 6. Always factor out any common terms, GCFs. Yes, that should always be your first mode to factoring. See if you can factor out GCF. Because a lot of the times it'll make things so much easier to factor in the end. Identify the blank of the last term of the trinomial, the factors. Next, determine which two factors either add up or subtract to get the middle term. Okay, so what are the factors of 6? That's my last terms, right? 1 and 6 and 2 and 3. Does everybody see that? So once you get those factors, you got to look at the signs and whether they add or subtract up to 5x. Now, in order to get a positive sum and a positive product, the only way you can get a positive product is if you do -1 times -6 or +1 times +6 or -2 times -3 or +2 times +3. That's the only way you can get a +6 product. Make sense? Okay, so now you look at these factors and you say which two would add up to 5x. right here. So x plus 2, x plus 3. Bada bing, bada boom, it's done. All you guys that do this decomp stuff, you need to do guess and check and get it fast, because you'll never finish the test if you do every factor by doing like this 5-step process. You have to do it fast. Okay, there's 4 types of simple trinomials. The sign in the sign, what do I want there? The sign in the middle is, the sign in the binomial is positive in both parentheses, because these are both binomials are positive. The sign in the binomial is negative. You see negative, negative. One middle sign, if you have this middle sign to be negative, then one of the binomials is negative. And if one middle sign is positive, I don't know, one is negative. I don't know. So really what you have to know is a negative times a negative is a positive times a negative is a negative, right? Like all the rules of integers. And then when you add them together, you need to know if you have a positive middle, then that means the bigger factor must be positive, right? Okay, so factors of 15. 1 and 15, 3 and 5. That's the only two. Now, it's pretty obvious it has to be 3 and 5, and then you play around with the signs. Why did I say it was pretty obvious it was 3 and 5? Because the middle term's 8, there's no way that 15 and 1 could ever get to 8, right? So, because this is positive, it can't, and this is positive, you can't have negative factors in the binomial, or negative signs in the binomial. So, x plus 3, x plus 5. Bam, done. Okay, how about this one? This one might be harder because factors of 36, there's a lot more of them. So the way I would do it is start at 1, then go to 2, and list it that way. So you don't kind of just randomly pick because you might miss one. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5, doesn't work, 6 and 6. Okay, so what's the only one that might work here? 3 and 12. Now we have to play around. In order to get a negative product, one of these numbers has to be negative. And then you look at the middle term. The middle term is negative. So that means what has to be the negative one? The 12, the bigger one has to be negative, because when I add this together, I have to get a negative sum, right? So what do I get in the first one? What is x squared? So x squared plus 3, x squared minus 12. Can I factor x squared minus 12 more? No, 12 is not a perfect square. Okay, next one up. Factors of 12. 1 and 12, 2 and 6, 3 and 4. Bingo, bango. Everybody see this is a nice, easy one. 3 and 4. Comes out right there. So just watch. You have x's and y's in there, right? So x plus 3y. That's the only way you're going to get 12y squared is if you have that second term to be a y in there, right? X plus 4y. So check. When I multiply x times x, I get x squared. Outer, I get 4xy. Inner, I get 3xy. Last, I get 12y squared. You should always check your answer, right? Okay, before you start trying to find factors of 9, what should you do first? Factor out a common factor of a 3. So then we get 3, and then what do we get here? X squared plus 2x minus 3. So what are we actually looking for? Factors of 3. That's easy. There's only 2, 1 and 3. We need a positive sum and a negative product, which means one of these has to be negative. Which one has to be the negative one? One has to be, because the bigger one makes the sign, right? Okay, so what's my final answer? 3 bracket x minus 1, x plus 3. Did we get that? Okay, I'm going to do as much as I can here until we get called down.